Hello. This lesson introduces graphing trigonometric functions by moving from the unit circle to the coordinate plane. So if you look at your note sheet, let's recall points on the unit circle. The radius is 1, so this is the point 1, 0 at 0 degrees. Up here at 90, this is the point 0, 1. At 180, this is the point negative 1, 0. And at 270, we have the point 0, negative 1. Let's take these points, focusing on the sign first. The sign, remember, is the y coordinate. So we're looking at these y coordinates of the points on the unit circle. And in my equation, x represents the angle measure. So here in my xy chart, I'm going to put angle measures for x. So I'm going to start with 0. I'm going to make this a little bigger. We're going to start with 0. And then go up to 90. Working our way around the unit circle, 180, 270. Coming back around, we'd be at 360, that's a full rotation. Go another 90 degrees and we're at 450. Another 90 degrees is 540. And another 90 degrees is 630. And we could keep on going if we wanted to. So now we're going to take a look at the signs of these angles. Again, remembering that sine is the y coordinate. So the sine of 0 right here is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is negative 1. And these values just keep repeating as we go around the unit circle. Let's do the same now for cosine. Remember that cosine is the x-coordinate of the points on the unit circle. So now we're looking at the x-coordinates of each of these points. I'm going to put the same angles in for x, 0, 90, 180, 270, 360, 450, 540, and 630. And now for my y values in the xy chart, again, we're putting cosine. So the cosine of 0 is 1, the cosine of 90 is 0, 180, we have an x-coordinate of negative 1. At 270, we're at 0. And here we're going back around the circle, so these points just keep repeating. So now what we're going to do is take these points from the xy chart and plot them on the coordinate plane. So this is sine, so we're going to look at our first xy chart and plot our points. Notice that along the x-axis, the angle measures are in degrees. We could do this in radians as well, but we're going to stick to degrees. So again, our independent variable, we've got angle measures along the x, and along the y will be our values of the sine. So 0, 0 is a point on our graph. 91 is a point. I'm going to make one up here. I'm actually going by 0.5s on the y-axis. So 90, the sine is 1. At 180, the sine is 0. 270 has a sine of negative 1. 360 has a sine of 0. If we worked backwards around the circle, going in a clockwise direction, negative 90 would have a sine of negative 1. There we go. Negative 180 has a sine of 0. Negative 270 has a sine of 1. And negative 360, we're back to 0. So if we draw in, connecting these points with a nice smooth curve, this is what the sine curve looks like. So this is the parent function, the most basic sine curve we could have. Some of its characteristics, we could talk about the domain. We can find the sine of any angle measure, so my domain is all reals. The range, if you look at your high points, are here at high points at 1, here and here. The low points are at negative 1. So our range has y values less than or equal to 1, greater than or equal to negative 1. The other thing to notice about this graph is that it goes through the origin. And when it's going through the origin, it's starting to increase. So I'm going to say it's going through the origin on its way up. All right, so that's what the sine looks like. Now let's go down here and do the same thing for cosine. So your XY chart is up above, and we're just going to plot these points for cosine. The cosine of 0 is 1. So that point is right here. The cosine of 90 is 0. The cosine of 180 is -1. Again, just getting these points from the XY chart. 270 has a cosine of 0, and 360, we're back up here at 1. And if we went around the circle in the clockwise direction, -90 would have cosine of 0, -180, cosine of -1, 270 is 0, and the cosine of -360 would be back up here at 1. So let's connect these points with a nice smooth curve. And this is what the cosine graph looks like. Has a lot of similar characteristics as sine. It has the same domain and range, all reals for the domain. The range, the y values go between 1 and -1. This graph does not go through the origin, and you'll notice here the y-intercept is 1, so cosine starts out at a high point, and that's an important point to distinguish it from the sine curve. So it starts at a high point. So that y-intercept is 0, 1. These sine and cosine curves are called periodic functions. Because the values repeat forever in regular intervals, which are also called periods. So this graph will continue to just repeat over and over and over. Same thing with the sine. So they're called periodic functions because their values repeat in regular intervals or periods. Now remember, these two graphs are the parent functions. They're the most basic sine and cosine curves that we could have. Now, of course, we're going to look at complicating things a little bit, spicing it up. So consider these equations. Y equals A times the sine of B, x minus h plus k, and the same equation that just has a cosine with it. So these equations have something else going on with the graph. It could be that they've been stretched out or shrunk, like a dilation. It could be that they've been translated, either shifted right or left or up or down. So let's consider what these variables mean in terms of our equation. So the amplitude is how high or low the graph goes above the midline. Or I should say from the midline, because it also goes below. So goes from the midline. And the midline is the line that cuts the graph right through the middle horizontally. So in the parent functions, the midline was the x-axis. So A tells us that. So in our equation, whatever this value of A is, right here, affects the amplitude. It's actually the absolute value of whatever A is considered our amplitude. If A is a negative number, that means the graph is flipped or reflected over the x-axis, and we'll talk about that a little later, okay? The period is how long it takes for the graph to complete one full cycle. How long it takes to complete one full cycle. The period of the parent function was 360 degrees. Every 360 degrees, the value is repeated. If we were talking in radians, a full rotation is 2 pi. So the period of the parent function is 2 pi in radians. B in our equation, this B up here, same as whether it's sine or cosine, affects the period. B is not the period, but it helps you find the period. Your period is 360 divided by whatever the value of B is. If we were talking radians, it would be 2 pi divided by B. But again, we're going to focus mostly on degrees with our graphs. Okay, now that leaves H and K. H and K deal with the translations. So the horizontal translation has a special name with periodic functions, and it's called a phase shift. It is just the horizontal shift. And you might remember with other functions, we've got this minus sign here in our equation that changes the shift to its opposite. So whatever is in the parentheses with the x gets changed to its opposite. So if you see x plus h, that's a shift to the left. And when you see x minus h, that is a shift to the right. So the opposite of what the sign looks like. Your vertical shift is just your shift up or down. Doesn't really have a special name. And the midline, that horizontal line that goes right through the middle of your graph, will also shift up or down depending on what the value is. And it's K, this value of K, that affects your vertical shift. So if K is positive, it moves it up. If K is negative, it moves it down. Okay, let's go over these examples, starting with example 1a. So in these examples, you're given the equation. We want to identify our values of a, b, h, and k to determine what our amplitude, period, and horizontal and vertical shifts are. So in this case, in this equation, a is 2, and that tells us our amplitude. So it's actually the absolute value of 2, which is 2. Here, we have a b value of 4. Remember, that is not your period, but helps you find it. So your period is 360 degrees divided by whatever b is. In our case, b is 4. 360 divided by 4 is 90. So our period is 90 degrees. The phase shift is what's inside here in parentheses with the x. That's our value of h. The value outside the parentheses is our value of k. So from this, I see a phase shift, a horizontal shift of 45 degrees, and because there's a minus sign, I'm going to do the opposite, and I know that's going to the right. The vertical shift, the k value is 1, it's plus 1, so the vertical shift is 1 unit up. Okay, similar with the next example, here our value of a is -3. So my amplitude is the absolute value of -3, which is 3. My amplitude's always going to be positive. There is no value of b here. There's really just a 1 outside of that parentheses. So that means my period is 360 degrees divided by 1, which of course is just 360 degrees. Your phase shift, that's your plus 90. You see the plus sign, and you know it's going to the left. So the phase shift is 90 degrees left, and the -5 at the end of the equation means the vertical shift is 5 down. Why don't you try part C on your own? Hit pause and give it a shot. Hopefully you found out that the amplitude was 1/2, the period was 360, phase shift 135 degrees to the right, and the vertical shift is 2 up. Okay, the last example, in example 2, you're given the graphs and asked to identify the amplitude, period, and vertical shift. In this case, you are told that there is no phase shift. So we know we don't have any value of h. It has not been shifted horizontally. So if I look at example 2 and I look at the amplitude, this line here is my midline. It cuts the graph right down the middle horizontally. My graph travels from that midline of y equals 2 up to 4 and down to -4. So it goes 2 above the midline and 2 below the midline. So that means my amplitude is 2. It's how high or low the graph goes above the midline. The period is how long it takes the graph to repeat. Let me erase this. So now we're looking at the graph starting here, going through the midline on its way up. Where does it do that again? Right here. So this piece of the graph is what repeats over and over. It took 90 degrees to make that full cycle. That is my period. Taking a look at the vertical shift, I know because my midline is now here at y equals 2, my graph must have shifted 2 units up. Remember that the midline of the parent function was the x-axis, so it has been moved up 2 to y equals 2, so that means every point on the graph has been shifted 2 units up. Now to determine whether this is sine or cosine, because I know there has not been a horizontal shift, I want to look at what the graph is doing at y equals 0. And it is going through the midline on its way up. Which graph does that, sine or cosine? That would be the sine. The sine is the graph that goes through the origin on its way up. So this is like my new origin because everything has been shifted 2 units up. So that's how I can tell that this is a cosine graph, because it goes through the midline on its way up. Maybe you should pause the video and try number 2 on your own. When you're finding the amplitude, you might want to find the midline first. This graph has a high point at +2 and a low point at -4. Halfway in between those points, halfway in between these points is y equals -1. That's our new midline. You can average the high point and the low point values. So 2 plus -4 divided by 2 is -2/2, which is -1. And that's our midline. That's the horizontal line that cuts through the middle of the graph. That means that my amplitude is how far above and below the graph goes from that midline. So the graph goes 1, 2, 3 units above the midline and 1, 2, 3 units below the midline. That means my amplitude is 3. The period is how long it takes to repeat. So here I'm looking at x equals 0, the graph is at a high point. It comes down, goes through a low point, it's back to that same high point here at 720 degrees. So it takes 720 degrees to complete this full cycle from high point back to high point. The vertical shift is again related to our midline. The midline used to be the x-axis for the parent graph. It's now at -1, y equals -1, so my shift is 1 unit down. And is this graph sine or cosine? Look at what it's doing at x equals 0, so on the y-axis. It's starting out at a high point, and the graph that starts out at a high point is the cosine. Thanks for hanging in there with me. This is Mrs. Walsh signing out. Let me know if you have any questions.